All right, good morning, guys. Happy Friday. At this point, you should have already completed your variables notes on page 8, and you have finished your variables Edpuzzle, and now you are working on understanding data tables. Okay, so you need to obtain from me a blank a data table here, and this is going on page 10 in your notebook. And the reason it's going on page 10 is because some people needed 2 pages to do the variables notes. Okay, so at the heading of your paper, I want you to write understanding data tables. And if you want, you can just not glue this down yet, just leave it because you don't know how much space you're gonna need up here. It depends on how big you write. Okay, so let's take a look at the data table, and I'm gonna read what it says, and then I want you to think about what this data table is showing. Okay, so we have our first column. Columns go up and down. Okay, size of wheels is the heading of that column, and then you have small, medium, and large. And then you have trial 1 and some values, trial 2 and some values, and trial 3 and some values. And then this last column here is average distance traveled, 11 centimeters, 16 centimeters, and 20 centimeters. So if this is the data table from an experiment, what was that experiment? What was the testable question? And what do you think the hypothesis might have been for this experiment? Okay, so you should have hopefully come up with, we're going to write this down now, the testable question and you should be writing this down as I'm writing this down, is do the size of the wheels affect the distance a toy car travels? Okay, and then right here I want you to put the hypothesis that you think. So I know you can see the data table, okay, but the second step of the scientific method would be hypothesis, and I want you to think, I think blank, whatever you think, size wheels will make the toy car travel the farthest. And you're going to put right here what size wheels you think, small, medium, or large, would make the toy car travel the farthest. And of course, you could cheat and look at your data table, but if you were doing your steps of your experiment, coming up with your testable question is first, and forming your hypothesis is second. Okay, so now we are conducting our experiment. So here we are at number 3, conducting our experiment. Okay, so conducting your experiment, you have to identify variables. So if you remember from yesterday's video, your independent variable is who versus who versus who, right? Your competition. You could also think of it as your cause and your cause and effect relationship. So if you see up here, I wrote the word effect, okay? So size of wheels affect distance of a toy car travels. Okay, so the size of the wheels, we're seeing if they are the cause of the effect of the distance of the toy car. Okay, so we are comparing small to medium to large wheels. So that would be our what variable? Okay, hopefully you came up with your independent variable. Independent variable. Okay. So what then is our dependent variable? Because we have a lot of other columns. Okay, there's not just one other column for us to default to. Okay, so here you see that you have trial 1, trial 2, trial 3. Okay, and then you have average distance traveled. So actually, all of these would be considered our dependent variable. okay? Because all this is representing is something in science that we call repetition. Okay, repetition. Now, repetition is used to ensure that your data is more reliable, more likely to be accurate. The word reliable means more likely to be correct. Okay, and the more often you test it, the more likely your data will be without error, right? Because sometimes maybe you could make a mistake in one of your trials and you could give one of those hidden advantages, right, that we talked about yesterday. You could accidentally leave a variable uncontrolled. Maybe you started the car a little more forward from the finish line and it appeared to travel farther, but it didn't actually. Maybe you mismeasured, right? Sometimes people read the wrong value on the meter stick, okay? So if you do it more than once, you're more likely to have your data be valid. So valid would mean correct or reliable, okay? So actually all of these are our dependent variables, but we are going to be looking at just this column as our dependent variable, since this column is going to be an average of these three. So if we were to make a graph, this is what we would graph. My computer screen is frozen. This, we would have our graph. Let's see if I can. There it goes. Okay. If we were going to graph, we would graph small, medium, large wheels and average distance traveled. And we would, in that instance, probably use a bar graph. Okay? So, as you can see, the average distance traveled was the farthest in the large wheels. Okay, and so this step would be analysis. Right, so you're making an analysis. So up here, you should include that this was the experiment. Here's your analysis. And so you would have that, looking at your data, you can see that the average distance traveled was the greatest farthest in the toy car with large wheels. Okay? And so then you could go back and look at your hypothesis and say, I was correct, I was not correct. And then if you were not correct, you would go back and rework your hypothesis and repeat your experiment with your new hypothesis. Okay, and we're going to end there for data tables today, and then we'll talk more about graphing later, okay, and how we would graph this information.